guys to practice. Later on, I can send you some solutions if you are still struggling with it, but it shouldn't be too difficult because everything that I did is pretty much the way you would have to do it. There isn't anything different, whether you have to make an exponent the subject of the formula, or it's something under a root that should be the subject of the formula. I think I went over everything. So for today, I want us to finish chapter 3.9. By the way, I sent you guys the test dates. Please take note of those dates. Most probably the test is going to be like a PDF that we send you to do. Then what you will have to do is write, and then you scan it, and then you can email it back to me, or there's a place on e-learning where you'll be able to upload it. So if it's a 2-hour test, we'll give you a few minutes extra just for you to scan it and send, and you must send it within that time. Otherwise, it's the same as if you didn't do the test. Okay, so if you're saying I don't have a scanner at home, you don't need a scanner at home. There are apps like Adobe Scan that you can download. It takes a picture and the picture comes out like a scanned copy. Okay, so keep that in mind. Please get ready. You can see the topics that will be in the test. Let me just see if I can open it here. So we have about 2 weeks-ish, and since tomorrow is a public holiday, we're going to miss 2 classes, so we need to go very fast. And that is why when I say go and revise this on your own, you actually need to go and do it. Okay, I cannot, let me just see. Okay, the test is the 5th May, and it'll end at solving cubic equations. So right now we are at manipulation of formulas. So there's 3 more sections that we need to cover before the test. Okay, so we might be going a little bit fast, but you have all the information, all the notes. If you don't have them, then I'll send the ones that we are still to do to you, and then you get ready. Okay, so today's class, we are doing the 2 exercises, exercise 3.9.1 and 3.9.2. So the previous one, 3.8, that was the manipulation of the formula, changing the subject of the formula. There's a lot of those questions. All you need to do is just practice, practice, practice. Let's start with exercise 3.9.1. So with the first question, you have pk squared over b cubed c cubed. This has to be divided by p to the power of 4, k to the power of 3 over bc cubed times p to the power of 3, k over b squared c to the power of 4. Okay, so to work this one out, when you are dividing, like I have my division over here, the division changes to multiplication, and then I write the reciprocal of the fraction that comes after the division. So I have p k squared over b cubed, okay, b, my cubed is not coming out, b cubed c to the power of 3, and then this will now change to a multiplication, and then I have to write the reciprocal of this function over there, so this fraction. So this is b c to the power of 3 divided by p to the power of 4, k to the power of 3. And then the last fraction, since it's a multiplication, I don't need to write the reciprocal. So this is p to the power of 3k over b squared c to the power of 4. Now here, because I'm multiplying, 3 fractions multiplying, what I can do is I can multiply everything in the numerator with everything in the denominator and then have a single fraction, then cancel out. Or even as they are now, I can cancel out some fractions. So some terms rather. So I see I have c to the power of 3. It cancels with that c to the power of 3 because one is in the numerator, the other one is in the denominator. So we're dividing those two. Then I see, let me use a different color. I have k to the power of 2. It's going to multiply with this k, and then I will get k to the power of 3. That k to the power of 3 is going to be in the numerator, and it will cancel with this k to the power of 3. So you see these two, they multiply together to give me k to the power of 3. They are in the numerator, so then they will cancel with the one in the denominator. Okay, then let me choose a different color. Then I see I have this p over here. Okay, the p cannot be highlighted. I have the p there, and when it multiplies with this p to the power of 3, I will end up with p to the power of 4. That p to the power of 4 will be in the numerator, and I have p to the power of 4 in the denominator. So this p and that one together make p to the power of 4 in the numerator. It must cancel with that p to the power of 4 in the denominator. Okay, so you can see what is left. Now I have a b over here. There's this b here, and then there is b squared over there. So I don't want to do too much. If it starts to get confusing, multiply what you have left and then try and do the cancelling again. Okay, so I will do that. So in the numerator, the only thing that is not cancelled is the b, so that will be the only thing left in the denominator. In the numerator, what is left, I have this b to the power of 3 left, I have b squared here, and I have c to the power of 4. So I must write all of those. But when I multiply b to the power of 3 with b to the power of 2, I should end up with b to the power of 5. And then I have c to the power of 4 left, so I should also write it. This is c to the power of 4. Okay, and then I can cancel because there is a b in the numerator as well as a b in the denominator. So b goes there once, and then here I will be left with b to the power of 4. So this is equal to 1 over b to the power of 4 c to the power of 4. Okay, so that's my answer. Sorry, person in the lobby. Okay, that's better. All right, then that's your answer. Then we do the next one. So still on the same exercise for question 2. Here I have a to the power of 5 b squared over c x cubed times ab over a squared x squared divided by a cubed b squared over x to the power of 5 and c to the power of 2. Okay, so we'll do the same thing. We will change our division to multiplication, and then we can see what terms in the numerator and denominator can we cancel. So the first fraction should remain as it is. So it's a to the power of 5b squared over c x to the power of 3 times, I'll put it as a dot just to save space. This is ab over a squared x squared. And then we said our division must change to a multiplication, and then I must write the reciprocal of the fraction that comes after. So I have x to the power of 5, c to the power of 2, and this is a to the power of 3, b to the power of 2. Okay, then I start cancelling. What do I have in the numerator? What do I have in the denominator? What are the terms that can cancel? So I start now in the numerator over here. I have a to the power of 5. Then in the denominator, I have a squared times a to the power of 3. Remember, when the bases are the same, you add the exponents. So this a squared, when I multiply it by a to the power of 3, I will get a to the power of 5. So I have a to the power of 5 in the numerator and a to the power of 5 in the denominator. Those two can cancel each other out. Then I have b squared, this b squared here, and that b squared, one is in the numerator, the other one is in the denominator, and because I am multiplying, I can cancel those two out. So this one will cancel with that one. So it's very important that everything is multiplying. You can see there's no addition anywhere here. If there was an addition, I cannot say there's a b squared in the numerator and a b squared in the denominator, then I cancel. No, it's only because everything is multiplying. Okay, then I see what else can I do. I see I have x to the power of 5. Okay, so you can see this x to the power of 3 and this x to the power of 2. When I multiply them together, I will end up with x to the power of 5, which I have in the numerator over there. So these two in the denominator give me x to the power of 5 when I multiply them, because their bases are the same. It's x and x. So when I'm multiplying terms where the bases are the same, I just add the exponents. So this two together, when they multiply in the denominator, divide by the numerator, they cancel out. Okay, so at any time if you are getting lost with your cancellations, just stop and say, okay, I'm not going to cancel anything more. I want to see what I have left. So I'll do that now and see, okay, I'm going to write down everything that is not cancelled out. So the a here is not cancelled, b is not cancelled, c squared is not cancelled. I will write that down. So this is a, b, c squared. That is what is not cancelled in the numerator. And then in my denominator, the only thing that is not cancelled is my c over here. So I write it down. Then you see, can I still simplify any further? The answer is yes, because I have a c here, and then I have that c there. So it's c squared divided by c. That is just equal to c. Because I'm dividing, the bases are the same, so I must subtract the exponents. The exponent of this c in the denominator is 1. So I say 2 minus 1, and that is why the final answer is just A, B, C. And then I'm done. Number 3, we have A squared B plus A B squared over 4A squared minus B squared times 8A squared plus 8AB over 3A squared B. Okay, this is still multiplying by another term, so I'll put it over here, times 4A squared minus 2ab minus 2b squared over 2a squared plus 4ab plus 2b squared. So you can see it in the notes. It's quite long.
Sorry
Now with
to
this one,
disturb,
yes? Say again?
Miss.
Yeah,
Sorry, Miss, to disturb, but I cannot see anything on the screen, Miss.
you
Maybe
cannot
the rest of
see.
the people can see it.
Is he the only
I'm
one who
saying, Miss, I
cannot
cannot
see
see
it?
any.
No, I'm asking the other
Huh?
people. Can anybody else see my screen?
Miss, I asked we can
You're breaking up. I
see.
can't hear you. What did you say?
Yes, we can see some of us.
Okay, some people can
Yeah,
see.
we can all see.
So it might be a
Yeah,
connection
I can
problem.
see, Miss.
So if you cannot see, maybe it's a connection, but again, I'm recording this so you can later watch it back. Okay. Now about the chat, I can't always read what is happening in the chat. Some people are typing comments. I can't see because I'm writing this down and going with my notes, so I can't follow the chat as well. So you just have to unmute yourself and ask the question. Okay, so this is what we have. Now with this one here, you are going to have to do some factorizing because you can see I have additions. I can't just say this a squared here must cancel with that one there. No, that is not correct. So I need to do some factorization because when it's factorized, then I have multiplications throughout. Then I can cancel things nicely. So to do that, I will start with the first fraction. With the first fraction, I look in the numerator. So remember we did factorizing. So you need to remember how to factorize. And with the numerator a squared, b plus ab squared, you say what do they have in common? What can I factor out? ab is the highest common factor, so you can take it out. So I'm just going to leave this to distinguish step 1 and then step 2. So I take out ab. Then to find out what you write in the brackets, you must always say a squared b divided by whatever it is that you took out. So if I took out 1a, there's another a left. If I take out 1b, there are no longer any b's left because over here there was only one b and I took it out over there. Then the same thing over here. If I take out 1a, there are no a's left. If I take out 1b, there's only one b left. So this is plus b, and then in the denominator we say what can we factorize. Now my denominator, you should be able to see that this is a difference of squares. So remember we did difference of squares, and I hope you remember how to write this. So I'm just going to write this. This is 2a minus b, 2a plus b. Now remember we spent quite a long time doing this difference of squares. So if you cannot remember, go back in your notes and try and figure out where did I get this from. The clue is that I'm using difference of squares. So I'll write this so later on you can refer to it. So this is difference of squares. So everything we have done previously, you will still have to use it. So don't forget anything. Okay, that's the first fraction. Then the second one, we are multiplying. Remember, all these fractions are multiplying. It's just that I don't have space to write them all in one line. So the one on top is multiplying the one at the bottom. Then the one at the bottom, I say what?
Miss,
Yeah,
I
is that
still
a
can't see the
question?
screen, Miss.
And if you
Miss,
cannot,
I still can't see the screen.
okay, everybody is saying they can see the screen. So I don't know what to do. So like I said, if you are the only one who cannot see it, because I'm recording this, you can watch it later and see what I wrote down. Okay? Okay. Right. So then the second fraction, we said what do they have in common? There's 8a squared plus 8ab. Let me scroll up to it. It's over here. The numerator 8 and a are common factors, so I'll take it out. And in the denominator, I don't need to factorize it because it's just a single term. So we don't factorize single terms. So the second fraction will become 8a when I take it out. So when I remove 8a from the first one, the 8 is gone, 1a is gone, then I have only 1a left. Then in the second one, I have 8ab. When I remove 8a, I am left with b. And then we said our denominator, it's a single term, so it stays there as it is. Then the third fraction, again, these three fractions, they're all in the same line multiplying. I'm only writing them like this because of space. Okay, then the third fraction, let's look at it. This is a quadratic expression. I hope you remember how to factorize quadratic expressions. We did some where there are two variables. I remember saying open your brackets, you put a, you put b, and then you work out the numbers the way that you normally do. It's fine. So here, but you can see that 2 is a common factor. Here 4, 2 is a factor, negative 2, 2 is a factor, negative 2 again, 2 is a factor. So before you even factorize it, you must factor the 2 out. And the same thing in the denominator. 2 goes there, it goes there, and it goes over there. So first you can start by factoring 2 out. So I will have 2 in 2, and then in the numerator I have 2a squared minus ab minus b squared. And then in the denominator, what I have is 2. We say 2 is a common factor, so I take it out as well. And then I have a squared plus 2ab plus b squared. And that's what I have. Okay, now the numerator and the denominator here, they don't cancel each other out. So I cannot say this a squared, it must cancel like that. No, because there is plus and minus there. You only cancel when you have a product. You have this multiplying with this, can cancel with something multiplying. Okay, but this two, those two can cancel each other out because they are multiplying. Okay, then we continue with our simplifying. Now I'm back at the top here, but everything again, remember, is a single line. Okay, it's just because of space that I'm writing it like this. Now if I look at what I have here in the numerator, there's nothing that can cancel with the first fraction by itself. But remember how we did the previous one. Where is this? You see here, I had the ones in yellow. They were not cancelling just with what they have in their denominator. They could cancel with a numerator in another fraction. So that is also what I'm going to do over here. So I see that this a here, let me pick red. So I see this a here is in the numerator, and over here I have a squared. Those two can cancel, but I will be left with 1a in the denominator over there. Okay, so something in the numerator of the first fraction can cancel with a denominator in the second fraction. The reason is because I am multiplying. Okay, only when I'm multiplying can I do that. Then also there's a b here in the numerator. There's this b over there. So those two will cancel. They are gone completely. I think with the red I forgot to show that this one is cancelled. So it's gone completely. But the one in the denominator over here, it's a that is left, because here it was a squared, and over here I have just a. So a cannot cancel with the entire a squared. It must only cancel with one of them. Okay, now this a plus b cannot cancel with this a plus b because they're both in the numerator. We cancel numerator and denominator, not two numerators together. Okay, so we can write down what we have left. So my steps will be separated by a line. So this is now the next step. Okay, sorry, I think I missed something here. I see there is also an a here. You see this a here is in the numerator, then it can cancel with that a over there. So this a squared in the denominator can cancel with this a from the first fraction and the second a from the second fraction. So a is completely gone, and b as well. So I can write down what I have left. So I have, for the first fraction, I have a plus b over 2a plus b, and then I have 2a minus b. That's the first fraction. And then for the second fraction, I have 8a plus b. So we can take a look at it. So what's left? It's this 8 is left, this a plus b is left, but in the denominator it's only 3 that is left. So this is that over 3, and then it's multiplying by the third fraction, which is this one over here. Here with the last fraction, only the 2's cancelled, so I need to factorize my numerator and the denominator. So this, again, I said is a quadratic equation. Remember how to factorize them. You open your brackets, you open your brackets. We do it in the same way, even when there are two variables, a and b. So like that, we said you put a there, you put a, you put, let me just scroll up so you can see. It's this one that I'm factorizing. Then you put a, then you put b, you put a, and then you put b. Now in the numerator, you ask yourself, I'm looking for two numbers that when I multiply them, the answer is -2. And when I add the two numbers, the answer is -1. And those two numbers are -2 and +1. So I put -2 and I put +1, which I don't even need to write it. And then because the coefficient over here is 2, I will then have to divide by 2, like that. So remember how we did that. And then the same thing in the denominator. I'm factorizing a squared plus 2ab plus b. So remember the a and b, it doesn't matter. You just open your brackets, put a, put b, put a, put b, and then find those two numbers and replace them the way we normally do. Then what I will have is two numbers. When I multiply them, the answer is 1. And when I add them, the answer is 2. The two numbers are 1 and 1. So this is just +1 and +1. So like that. Okay, and here I don't need to divide by anything like I did up here because the coefficient of a over there is 1. So I'm going to simplify that part. Just scroll up. Okay. So I will put this in red. So if you're reading these notes later, you will remember this is just the working. So you should know how to factorize that. So when it's factorized nicely, I should see this. This is a minus b, because 2 divided by 2 is 1. And then over here, this 2 must go up there. So this is 2a plus b. And then in the denominator, it is just a plus b, a plus b. So I'm multiplying this fraction, this one here, and that one. The one in red is showing how I got this one over here. Then, because all the three fractions are multiplying, I can cancel numerators and denominators. So I will do that. Let's start. See, I can see I have a plus b here in the numerator, and there is an a plus b in the denominator. So those two will cancel each other out. And let me just use a different color, even though the terms are the same. I see this a plus b in the numerator, and there's still an a plus b in the denominator. So those two will cancel each other out. Then in the numerator here, I see 2a plus b. This is in the numerator of the third fraction, and 2a plus b is in the denominator of the second fraction, so I can cancel them. Let me just use a different color. So this one here and that one there, those two can cancel each other out. Okay, then if it's getting confusing what is canceling, what is not canceling, just write what is left so far and then continue from there. Okay, so I will have one fraction, then I write the first fraction. The only thing left is this. When terms cancel, it means there's a 1 because you are dividing. If you divide 5 over 5, it doesn't cancel to give me 0. I get 1 because 5 into 5 goes once in the numerator and 5 into 5 goes once in the denominator. So what I have is 1 over, I have 2a minus b. Notice the 2a minus b here is in the denominator. It doesn't magically go into the numerator. So I don't want to see it was in the denominator, then all of a sudden it's just in the numerator. You need to justify that. How did it go to the denominator? Because to the numerator, because I see that a lot. Students see that, okay, there's nothing left, or the a plus b cancelled with something, so they think the denominator should now become the numerator. No, when we cancel with multiplication or division, it means we get 1. So in the numerator, I must see 1. Then for the second fraction, I have 8 left and 3, so I'll write that down. So these are still multiplying, so it's 8 over 3. And then in the third fraction over here, I have a minus b. And again, you see the entire denominator cancelled out, but it doesn't mean I don't have to write it. If the denominator is 1, you don't necessarily have to write it, but I just want to keep that feel that it is a fraction. So I'll write it like that. Then you see, okay, is there anything else that can cancel? No, there's nothing else. I cannot cancel this one, 2a minus b with a minus b, because those are not the same thing. So I cannot say, okay, I'm going to cancel. Let me just see. I cannot say, okay, this a will cancel with that one, this b like that. No, that is not how we cancel things. So look at how I've been canceling. It has been the entire term and not just a part of it. Okay, and I was canceling things that are multiplying, not things that are separated by a plus. So here, my brackets are multiplying. So I am canceling brackets that are multiplying. Everything that I was canceling over here, the 8 and the a plus b, they are multiplying, so I can cancel those. I did not cancel anything that was separated by a plus. Everything was multiplying. Okay, then if there's nothing else that can cancel, then we just work out this fraction. I will say numerator times numerator times numerator. So it's 1 times 8 times a plus b. So what I will have is this. So I will have 8 and then I put it in brackets a minus b to show that the 8 must multiply everything. So if I write this, let me just do this. Same thing in the denominator. This is 3 2a minus b. Now I know somebody was thinking, can I not write 8a minus b over 6a minus b? No, this is wrong. That is not how you multiply. So when I see this in the test, I will just write it like I have done here with an exclamation mark. That is wrong. The 8 must multiply the a and also the b. That's why it's in brackets. I always say you meet two people, you are alone, you are the 8, you meet two people, A and B, they came together, you must greet both of them. Otherwise, you're very rude. You cannot just say, I will greet only the A and then ignore that B. No, you must greet both of them, and multiplication is not rude. So you greet everybody. Okay, so that's that one. So you cannot simplify it any further. Again, the A's here do not cancel because they're not multiplying. It's a sum. So you cannot factorize it any further. You leave it like that. Then, okay, let me try and scroll up. Okay, so now the next question. This is number 4. We have x squared minus x minus 2 over x squared plus 3x multiplied by 4x over x minus 2, and again this is multiplying by x to the power of, not 5, x to the power of 2 plus 5x plus 6. This is all over x squared plus 3x plus 2. Okay, so again, all these three fractions are multiplying, but I cannot just start cancelling. Oh, I see an x squared here. It will cancel with, I don't know, x squared like that. I see an x here. It will cancel with that. No, because there is a minus and there's addition separating them. So we do not do that. So first thing you must do when you see a question like this, you should think, okay, I need to factorize. Then I cancel the factors out. Okay, so when I do that with the first term, this is a quadratic equation. You should know how to factorize this one. So again, this line just shows next step. So when I factorize this, I will get x minus 2, x plus 1. So you can try it, see if that is the correct answer. Remember how we factorize. And then in the denominator, x is a common factor, so I can take the x out. So this is x plus 3. And then the second one, it's a single term. It's just x. And in the denominator, x minus 2 cannot be factorized. X and 2 don't have any common factors, so I just leave it like that. And then I will multiply it by the third fraction. The third fraction, I also need to factorize it. So it's simple. Look for the numerator, you look for two terms, you multiply them, two numbers, you multiply them, the answer is 6, you add them, the answer is 5, so it's obviously 2 and 3. So I have x plus 2, x plus 3, and then in the denominator over here, look for two numbers, you multiply them. So this one, two numbers, you multiply them, the answer is 2. When you add them, the answer is 3. So it's obviously 2 and 1. So then you factorize. This is x plus 2, x plus 1. Now it's factorized. Then now you can start canceling. So you cancel things that are separated by a bracket, or you can see that they're multiplying. I don't cancel terms that are separated by a plus. That is not allowed. So I start my canceling. Okay, so I see x minus 2 here. in the numerator and an x minus 2 in the denominator. Remember, it is numerator cancelling with denominator. I don't cancel two terms in the numerator. So those two cancel because they are the same. One is in the numerator, the other one is in the denominator. Then I see x plus 1 here in the numerator and x plus 1 over there in the denominator. Now it doesn't matter that they are from different fractions. One is from the first fraction, the other one is from the second or the third. When we are multiplying, it's all just one fraction. Okay, so multiplication, you don't distinguish, no, you came from the first fraction, you came from the second one. No, it's all just one fraction. With addition, yes, there's a distinction. And here we are multiplying. So this is all just one single fraction. So I can cancel like that. Then let's see if there's anything else we can cancel. Okay, I see there's an x over here in the numerator and x over there in the denominator. So those two will cancel out. Then I see there is an x plus 3 in the denominator and an x plus 3 in the numerator. Those cancel. So this is from a denominator, from a numerator, and those cancel. And then this x plus 2 is in the numerator. This x plus 2 is in the denominator. Those two will cancel out. Then you write down whatever is not cancelled out, and it must keep its place. If what is not cancelled is in the numerator, it must stay in the numerator. If what is not cancelled is in the denominator, it must stay in the denominator. And if all the terms in the numerator are cancelled, then you write 1. I think that one I need to stress it. If all the terms in the numerator are cancelled, your numerator becomes 1, okay? Or -1 if there was a negative sign. The numerator doesn't just disappear or the denominator just becomes the numerator. No. If it was in the numerator and it wasn't cancelled, it must stay in the numerator. If it was in the denominator and it wasn't cancelled, it must stay in the denominator. Everybody must stay in their place. Okay, so let's see. The only thing that is not cancelled is 4. So with the first fraction, when I look at it, everything is cancelled. With the second fraction, when I look at it, only the 4 is not cancelled. And with the last one, when I look at it, everything is cancelled. So my final answer, this is just equal to 4. So you can see this is what we started with. It looks so complicated, but it is actually just equal to 4. Okay, so the technique we will have to use, or what you will need to know, is how to factorize. So you definitely need to know how to factorize. Okay, so please make sure you know how to factorize, whether it's getting a common factor out, whether it's not completing the square, whether it's a quadratic equation, how to factorize that one, or the difference of squares. You should know how to use any of those to factorize and cancel. Now homework, I will say, so homework number 5. So this is exercise 3.9.1. So question 5 and 6, go and try them. Okay, so those involve the techniques that I have done here. So there's nothing complicated about that one. Then we move on to the next section. This is now exercise 3.9.2. Okay, so with this one, what you will have to do is combine fractions together. So I'll look at number 1. We have 5 over x minus 2 plus 4 over x plus 2. Now we're adding. Here we're not cancelling because it's not multiplication. We have to combine it, and our final answer must be a single fraction. Now remember, when we add fractions or we subtract fractions, the denominators must be the same. And you must always try and work with the lowest common multiple as the denominator. Now it will work even if you don't use the lowest common multiple, you just use a common multiple, it will work, but you will make your work a lot more because you will still have to simplify. And when we get to more advanced fractions, if you are going to work with a lot of with multiples that have higher powers or there's more terms, it's very easy to make a mistake. So always try and work with the lowest common multiple. Okay, so here my denominators are obviously not the same. So I ask myself, what is the lowest common multiple of x minus 2 and x plus 2? That is just the product of the two of them. So just like you used to do, make one big fraction. Sorry, I think somebody wants to join the class now. Okay, I think they're in now. Okay, they're in. Right, so we make one big fraction. The denominator is the product of the two, so you have x minus 2 and then x plus 2. Then here you will say this is 5 multiplied by x plus 2 plus 4 multiplied by x minus 2, just the way you would do it if your fractions had denominators that were numbers. Okay, so you make one big fraction, the lowest common multiple in the denominator, and then what you do is you adjust your numerators so that they actually satisfy the equation. Okay, then here the only thing to do is just multiply, and remember how we multiply. The 5 must multiply the x, it must multiply the 2. The 4 should multiply the x and also multiply the minus 2. So here I have 5x plus 10 plus 4x, and then I have minus 8. This is all over x minus 2, x plus 2. So avoid multiplying out the denominator, because usually what happens is after you've simplified your numerator, there are terms that can cancel. It's not always the case, but a lot of times there are terms that can cancel. So if you multiply out the denominator, you'll sometimes see that you have to go back and factorize. So you can leave it like this for now. And then collect your like terms. So remember, like terms, the exponent, the variables are the same and the exponents are also the same. So those two, those are like terms. And then that one and that one, those are like terms. So you say 5x plus 4x, that should be equal to 9x. And then 10 minus 8, that is just positive 2. And then my denominator, I can leave it like that. You can also multiply it out. This is fine. There's nothing wrong with that. But you could multiply it out, x plus 2. And then when you do that, you get x squared minus 4. So either of those is fine. And number 2. So we're still on exercise 3.9.2. So those are the last questions in the notes that I sent you. So go over them. So I have x over x minus 2 plus x plus 1 over x plus 2. So I have to combine these two fractions. And again, when we're combining fractions, the denominators must be the same. So I make one big fraction and then the lowest common multiple. And the lowest common multiple in this case is the product of the two. The product of the two is not always the lowest common multiple. Like if I give you a fraction half plus 1 over 8, just write this and remove it. If I say half plus 1 over 8, the lowest common multiple of these two is 8. So I don't need to change it to 16. Okay, that means I will have to do a lot of simplifying at the end. So I want to avoid making it too complicated from the beginning. And then I multiply as always this x, multiply with x plus 2, and then plus x plus 1. I put the whole thing in bracket to show that the entire numerator over here is the one that is going to multiply with that term. So it's x minus 2, like that. Okay, then multiply out your brackets. Everybody must greet the person they did not come with, like that. So if you came with somebody, there's no need for you to greet them. Then you multiply x times x, you get x squared, x times 2, this is 2x, and then x times x, this is x squared, x times minus 2, that is minus 2x, x times 1, that is x, and then I have minus 2. Let me just see, I have minus 2. And then my denominator, for now, I will just leave it like that, in case there are terms that can cancel when I've simplified. Okay, so in the numerator, you collect your like terms. How many x squareds do you have? I have this one and I have that one. So that is 2 x squareds. And then x, you can see I have 2x minus 2x, that means 0, plus 1 is just 1. So I have plus x. And then the only constant is minus 2. Okay, just check if I did this correctly. X, 2x, no. Okay, x squared, minus 2x, x, and then minus 2. Okay, it looks like I've done it correctly. Then my denominator, we just leave it the way it is. Then I have x plus 2. Okay, and then okay, I see the problem. Okay, in the book, I see that there's a subtraction over there, but I've changed it to plus. So in the notes, you'll see there's a minus, but you can also work that one out as homework. Then you have this one over here, where you have 2x squared plus x minus 2 over x minus 2x plus 2. You say, can I factorize my numerator? That means I'm looking for two numbers that when I multiply them, the answer is negative 4. And when I add them, the answer is positive 1. No, you cannot find those two numbers because it's only 1 and 4 and 2 and 2. So even if one of them is positive, the difference between them is not 1. So it is possible that you can end up with something like this, where you cannot factorize the numerator. It's fine, you leave it like that. But the one in the notes, like I said, I made a mistake and made this plus. It should be minus. You can try that one. It simplifies and looks much better than this one. Okay, so number 3. I have 1 over x minus 2 squared minus 3 over x squared minus 4. Okay, so again, before you just go and make the new fraction with the denominator that has a product of the two of them, first try and factorize as far as possible. Can your denominator be factorized? Factorize it. The first one, the denominator is already factorized, but if I wanted to see that, I can write it as x minus 2, x minus 2. That's what squared means. Okay, so when I say something squared, it means I must multiply it by itself. So x squared is x times x. Y squared means y times y. 10 squared, 10 times 10. X plus y squared means x plus y times x plus y. And then the second one, the denominator, I factorize it using the difference of squares. So this is x minus 2, x plus 2. Now I look for the lowest common multiple. Okay, now I see that both of these fractions, they have an x minus 2. They have an x minus 2. One has another x minus 2. The other one has an x plus 3. So I can tell that the lowest common multiple will obviously have an, sorry, I didn't want to use this color. The lowest common multiple will have an x minus 2, and then it must contain this second x minus 2 because the first one has it. So it must contain another x minus 2, and it must also contain this x plus 2 because the other term also has it. So this is x plus 2. Okay, now in the numerator, I look at this denominator here and I look at the one that is the lowest common multiple. Then I ask myself, what is the difference between this denominator here and that one, or what is missing? Now what is missing from here? We have the x minus 2, x minus 2. What is missing is the x plus 2. So that is what I will multiply the 1 by. So I will say 1 multiplied by x plus 2. Because if there was an x plus 2 here, if there was an x plus 2 here in this denominator, it will be exactly the same as this one here. So because it's missing, I'm going to multiply the 1 by it. Then I do the same thing over here. I look at this denominator. What is the difference between this one here and that one? The x minus 2 is there. X plus 2 is there. So it's missing another x minus 2. So that is what I will multiply the 3 by. So 3x minus 2. Now, if this is just a warning, even if it's not wrong to do this, I'll put it in red. So this is like a caution. Okay? Sometimes there are things that we can do that are not wrong, but the effort it takes is not even worth it. You can make another big fraction like this, and then you make the denominator, what was it, x plus 2 squared, and then I have x squared minus 4. You can do that, but I am telling you what you will have up here when you multiply. Let me just write it. It will be, what is it? It's 1 x squared minus 4 minus 3 x minus 2 squared. What you will have, and even this one, it's not even that complicated to do. I'm sure you can figure it out.
Miss,
Now when you have, yeah?
Miss,
Yes.
I think we have to use the positive in the first bracket. The denominator. Ne?
Was it a plus? Let me see if I've copied it correctly. X minus 2, x minus 2. I'm not following.
That must be it must be a negative.
I mean this one here. I'm trying to see. Let me see. Okay, that is the question. Okay, I don't understand where you mean which positive. It should be negative.
Yes.
Yeah, it should be negative. Yes, thank you. So here, like I was saying, what you have here is not even that complicated. But when you have 3 or 4 fractions that you must add like this, the work that you will have to do, you will see that the number of marks awarded for that is not even worth it. So that is why I will say this is just a caution. Try and avoid making another fraction where the denominator is just the product. Rather go for the lowest common multiple. Okay, so doing it like this, it's not wrong. Okay, it is just because it is going to take you a lot of time and a lot of effort to do it. Okay, so we continue with what we had. Let us multiply. So we're here. Let me change the color back. Okay, so what I do is I will multiply. The 1 will multiply like that. This will multiply out like that, and then we see if there's anything that can cancel. So when I multiplied, I got x plus 2 minus 3x plus 6. This is all over x plus 2 x minus 2 squared. Let me see. Okay, that is x plus 2 and minus 3 plus 6. Okay, that's fine. Okay, so this is what you have. Then in the numerator, you see, are there any like terms to cancel out or combine? So you have x and minus 3x, which is just minus 2x. And then 2 plus 6, that is 8. And then in the denominator, you can leave it like x plus 2, x minus 2 squared. Okay, so that's what I have. And usually we like to write the positive term first. So you can even factorize 2 out in the numerator. There's nothing wrong with that. But I don't think it really makes it any better. So here you can rewrite it as 2x over x plus 2 and then x minus 2, and that is being squared. So that's what we have. Okay, and if you had done it like this, trying to simplify it to this part, because this will be your final answer, and you cannot just leave it in this form if there are terms that can cancel out. So you will now have quadratic equations that you must factorize. You will see that there are terms that can cancel. That is going to be a lot of work. Okay, but it's not wrong. It's just that it is very, very long. Okay, I would like us to do just one more because we're not having class tomorrow. So let us try and finish these questions, and then the rest of them you can try them, and then maybe tomorrow I can send you the solutions of what I got, and then you can compare and see if what you did is correct, because with these ones they just take practice. All you need to do is practice. That's it. I will do okay, I'll just do number 4. Number 4, I have 2 over 6y minus 2 plus y over 9y squared minus 1 minus 2y plus 1 over 1 minus 3y. Okay, so again, you must try as much as possible to use the lowest common multiple as your denominator. To see what the lowest common multiple is, factorize your denominator as far as possible. So for the first one, if I were to factorize the denominator, I will have 2, and then I have 3y minus 1. I factor out 2 in the denominator, and then for the second one I must use a difference of squares. So if you've practiced, you will know just by looking at something, difference of squares. So this one is y, and then I have 3y minus 1, 3y plus 1. And then for the third fraction over here, I am going to change it slightly, or I'm going to factor out negative 1. The reason I do that is because I look at these other terms. It's 3y minus 1, 3y minus 1, but this one is the opposite. It's 1 minus 3y. So I want to change it to 3y minus 1. So to do that, I can factor out negative 1. So I still have minus, and then the numerator stays as it is. And then in the denominator, I take out negative 1, just write it, then it's 3y minus 1. And before I proceed, I can cancel out in the numerator and denominator for that specific fraction, if there's anything. So I'm not canceling across fractions because I have addition over here. So I have addition and subtraction. I cannot cancel something from this fraction with that one, no. But I see in this fraction itself, there's a 2 in the numerator. It can cancel with the 2 in the denominator. So I will do that. So we see that this 2 here in its own fraction, they can cancel. And see, everything in the numerator is cancelled. It doesn't mean I'm going to take this 3y and bring it up. No, we said that if everything in the numerator, where did I write that? If all the terms in the numerator are cancelled, then your numerator becomes 1. It doesn't become 0, or you don't make the numerator, the denominator, the numerator. No. Okay, so I will have 1 over 3y minus 1. For the second fraction, nothing can cancel. I don't say this y must cancel with one of the y's over there. No, cannot cancel with part of the bracket. Either it must cancel the entire bracket or nothing at all. Okay, so just to show that this is the next step, I'm going to separate it a line like that. Okay, so I have y over 3y minus 1, and then 3y plus 1. Okay, and then the second one here, this negative 1 and this negative can actually cancel because I'm subtracting. This negative belongs to this whole bracket. It doesn't belong to the negative, it doesn't belong to the 2y. It belongs to 2y plus 1. And that is why those two can cancel, or negative divided by negative, and then I can get a plus. So this is now a plus. And then I have 2y plus 1 over 3y minus 1. Then, now that my terms are factorized nicely, for the next step, I must make one big fraction, and then I look at the denominator that I need to make. So you can see here I have 3 fractions and 4 terms from the fraction. If I were to say this times this is this times this times this times this, you have that to a power of 4, and imagine how difficult that is going to be when you have to simplify it. But now if I make my new fraction, I see, okay, this first fraction over here has 3y minus 1 as the denominator, so the lowest common multiple must obviously have 3y minus 1. Then I go to the second fraction. Okay, the 3y minus 1 is already there in the denominator. The only thing missing is this 3y plus 1. So I put it there. So it's 3y plus 1. And then I go back the third fraction. The third fraction is 3y minus 1. Oh, 3y minus 1 is already there, so I don't need to add anything to it. The only thing that is missing for here is that one there. So this is my lowest common multiple, which is much simpler than if you multiply this times this times this times this, because multiplying 4 brackets means you multiply the first one with the second one, you get an answer. Multiply that with the third one, you get an answer. Then multiply with the fourth one. And in the test, you will have maybe 6 brackets. And if you do not pick the lowest common multiple, by the time the test is done, you will not even be finished with that one question. Okay, so then to find out what goes in the numerator, you must ask yourself over here, this is what it contributed to the numerator. So it contributed this part. So this 3y plus 1 is missing. So that's what I will multiply 1 by. So I'll say 1 times 3y plus 1. Then the second one, this 3y minus 1, it's represented over there. The 3y plus 1, it's represented over there. So it's not missing anything in order to become this denominator. So I just write the y as it is. So it doesn't need anything. Then this one over here, 3y minus 1, what is missing? 3y plus 1. So that is what I will multiply the numerator by. So plus 2y plus 1, and then I have 3y plus 1. Okay. And again, if you had written 4 terms multiplying, you will see that your terms in the numerator, there's 3 brackets multiplying. Each of them has 2 or 3 brackets that you have to multiply, and it'll take you forever to do that. So now you just multiply. I have 3y. So this is the next step, just to separate them. I have 3y plus 1 plus y plus this one. Remember how we multiply the friends going to the party, how they must greet each other. Then I have plus 2y times 3y. This is 6y squared. And then 3y times 1. This is 2y. And then 1 times 3y. This is 3y. And then 1 times 1. This is just 1. Let's see if I can write that there. It's refusing. There's a 1 there. This doesn't look nice. Plus 1. Okay. And then the denominator, let's just leave it like that for now. And then let us see if we can simplify our numerator. See how many y squareds do we have. It's only the 6 of them. So I have 6y squared. Then how many terms with y? Let me just circle them. There's this 3y. There's this plus y. There's 2y. And then there is 3y. So I have 3 plus 1 is 4. And then 4. And then 4 plus 2 is 6. And 6 plus 3 is 9. So I have plus 9y. And then 1 plus 1, that gives me 2. Then this is 3y minus 1. Then 3y plus 1. Okay, you can try, see if the numerator can be factorized. You look for 2 numbers, you multiply them, the answer is 12. And when you add them, the answer is 9. I can't think of any 2 numbers like that because it's 12 and 1, 6 and 2, 4 and 3. None of those add up to 1. So this is how you will leave your answer. This is in its simplest form. So this is what I will want to see in the as your final answer. So if you had multiplied lots of brackets over here, trying to get to this one over there, it's going to be a challenge. Okay, again, there will not be any class tomorrow, so more homework. So this is exercise 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4 3.9.2, you should do the rest of the questions. So I did 1 up to 4. There's 5, 6, 7, 8, and 9. So it's just a few of those, and then we will be done with that. So try and see if you're able to do that. Remember everything I said on how to do it. You only cancel when you are multiplying fractions. All the fractions are multiplying, or when terms are factorized. You never cancel terms that are separated by plus or minus, where you only cancel one of them but not everything. It doesn't work like that. So go and try those questions, and then I'll see you guys on Monday. Sure.
Thank you, ma'am.
Okay. Yeah, then we have to start with the next chapter, because the test is going to cover like 3 more weeks of stuff. So we need to go a little bit faster. Okay, do you have any more comments, questions, or are we fine? Yes.
The 3.9.2, did you send it on e-learning or is it on the group?
No, it's part of the notes that I sent you, I think. So does that mean you didn't go through them?
Oh, not yet, ma'am. I was a bit behind.
It's I think let me just see if I can see it there. I don't remember how I sent it, but I know it was 3.8, and it should be the last 2 questions of 3.8. Let me just
I
quickly.
just want to find out if it's on.
You're quite
or
soft. I cannot hear you.
I'm saying I just wanted to find out if it's on e-learning or on the group, and I'll be able to find it.
Yes, they are on both. So it is part of the notes that I sent you with the manipulation of formula. So you'll find it at the end.
Okay, no, then I'll find it.
Right.
Because I'll not be catching up.
Okay, I didn't hear what you said, the last part.
No, I was saying I'll find it, ma'am. I was still catching up.
Okay. Okay. All right. Any other comments? If not, then please go and study. Those ones on manipulation of formula, you need to practice. That is really the only way. I can give you all the solutions, but if you have not practiced, you will definitely not get it. Okay, so please go and practice, and I'll see you guys on Monday.